Have you ever wished you could turn back time? Maybe to fix a mistake, relive a happy moment, or just see what the past was really like. It's a captivating thought, but as we all know, time stubbornly marches in only one direction, forward. But why? Why can we move left and right, up and down, but not back and forth in time? This is one of the biggest and most fascinating mysteries in all of science. Today, we're going to dive deep into this question and explore the concept known as the arrow of time. To start, let's think about our everyday experience. You scramble an egg, and it becomes a gooey mess. Have you ever seen that gooey mess unscramble itself back into a perfect, raw egg? Or what about a drop of ink in a glass of water? It spreads out, coloring the water, but it never gathers itself back into a neat little drop. This one-way street for processes is a fundamental observation about our universe. Things tend to go from a state of order to a state of disorder. This, my friends, is the heart of the matter. The scientific concept that explains this is called entropy, which is a key part of the second law of thermodynamics. Now, entropy might sound like a complicated science term, but the basic idea is pretty simple. Entropy is just a measure of disorder or randomness. The second law of thermodynamics states that in an isolated system like our universe, for example, the total amount of entropy can never decrease. It will either stay the same or, more likely, it will increase. Think of it like building a sandcastle. It takes a lot of effort and specific placement of sand to create an ordered structure. That's a low entropy state. But what happens if you just leave it? The wind, the waves, or even a clumsy seagull will eventually knock it down, scattering the sand grains randomly. That scattered pile of sand is a high entropy state. There are countless ways for the sand to be scattered, but only one, or very few, ways for it to be a perfect castle. The universe naturally moves towards the states that are most probable, and disordered states are vastly more probable than ordered ones. So, how does this relate to time's arrow? Well, the Big Bang Theory suggests that our universe began in an incredibly hot, dense, and highly ordered state. Imagine all the energy and matter of the entire universe packed into a tiny, perfect point. That's an extremely low entropy condition. Ever since that initial moment, the universe has been expanding, cooling, and becoming more and more disordered. Stars form, burn their fuel, and explode. Galaxies drift apart. Energy spreads out. This constant, irreversible increase in universal disorder is what gives time its direction. The forward direction of time is simply the direction in which entropy increases. The past is the low entropy state, and the future is the higher entropy state. You might be thinking, but wait, I can create order. I can clean my room or build that sandcastle. And you're right. On a local level, we can decrease entropy. But to do that, you have to expend energy. Your body burns calories, a chemical process that releases heat and increases the overall disorder of your surroundings just to tidy up your desk. The total entropy of you plus your room actually goes up. So even when we create pockets of order, we're contributing to a greater increase in disorder for the universe as a whole. Life itself is a beautiful example of a temporary, localized fight against entropy, but it's a fight we can't win on a universal scale. But is entropy the only explanation? Some physicists think there might be more to it. Another fascinating idea comes from the expansion of the universe itself. Since the Big Bang, space has been stretching, carrying galaxies along with it. This cosmological arrow of time points in the same direction as the thermodynamic arrow from the Big Bang towards an ever-expanding future. Are these two arrows linked? Most scientists believe so. An expanding universe provides the room for disorder to grow. If the universe were static or shrinking, the dynamics of entropy would be very different. Then there's the psychological arrow of time. This is our subjective experience of time passing. We remember the past, but we don't remember the future. Why? This is likely tied to the thermodynamic arrow as well. The process of forming a memory in our brain involves creating new neural connections and storing information. This process, like all physical processes, increases entropy. Your brain is essentially a memory machine that records the wake of increasing disorder. We perceive time as flowing from the state we can remember the past to the state we could and the future, because the very act of remembering is a physical process that follows the second law of thermodynamics. So, could time ever run backward? For that to happen, the total entropy of the universe would have to start decreasing. Broken eggs would have to reassemble, spilled ink would have to gather itself, and all the scattered heat and energy in the cosmos would need to reconcentrate. From everything we know about physics, this is so astronomically improbable that it's considered practically impossible. The number of ways for things to be disordered is just infinitely greater than the number of ways for them to be ordered. The universe is simply following the path of least resistance, the path towards maximum probability. It's a mind-bending concept, isn't it? Our deepest experience of reality, the relentless, one-way flow of time, is rooted in the universal tendency towards mass. It's not a force pulling us forward, but rather a statistical certainty pushing us away from a highly improbable, orderly past. The arrow of time isn't a feature of time itself, but a feature of the universe that time takes place in. This understanding can change how we view our lives. Every moment is unique and irreversible. It reminds us to cherish the present because we can't go back and relive it. The arrow of time gives our choices meaning and our actions consequence. While we might not be able to time travel to the past, we are all constantly traveling into the future, one moment at a time, co-creating the next chapter in the universe's ever-unfolding story of increasing entropy. What do you think? Does this explanation make sense to you, or do you have another theory about why time only moves forward? Let me know your thoughts in the comments below. I'd love to hear what you think about this cosmic mystery. Thanks so much for joining me on this journey through time and entropy. If you enjoyed this video and want to explore more big questions about our universe, please give it a thumbs up and consider subscribing to the channel. It really helps us create more content like this. Until next time, stay curious.